In this video, we'll do an example using the quotient rule. Let's start with the function f of x is equal to x squared minus 2 divided by the quantity x to the fourth plus 5. All right, the graph of this function is shown here. All right. Notice on the graph there are 3 points where the graph has horizontal tangent lines. These points are right here. There's a horizontal tangent line. Right here, there's a horizontal tangent line, and right here, there's a horizontal tangent line. Okay. One is clearly at x equals 0. This one's clearly at x equals 0. It's on the y-axis. What are the x values of the other 2 points? All right, well, let's outline a strategy for solving this problem. Remember, all right, the derivative tells us the slope of the tangent. So we want to find f prime, okay? All right, the slope of the tangent, well, maybe I should say horizontal lines have slope 0, so set f prime of x to 0 and then solve for x. Okay. All right, well, let's look back. We recall what our function is. We have f of x is x squared minus 2 over x to the fourth plus 5, I believe it is, plus 5. So the first step is find the derivative. F prime of x, now since this is a quotient, we'll use the quotient rule. We'll have x squared minus 2. All right, make two copies of this. X to the fourth plus 5. X squared minus 2. X to the fourth plus 5. All right, in the first copy, remember, I take the derivative of the numerator. In the second copy, I take the derivative of the denominator, and then I subtract them. This gets divided by the denominator squared. So this will be, when I take the derivative of x squared minus 2, well, the derivative of x squared is 2x. The derivative of 2 is 0, so I just get 2x times x to the fourth plus 5 minus x squared minus 2 times the derivative of x to the fourth plus 5. The derivative of x to the fourth is 4x to the third. The derivative of 5 is 0. So I have this expression, again, divided by x to the fourth plus 5 squared. Let me copy this expression because I'm going to have to move down to the next page. All right, so then recall we're finding f prime of x, and it's given by this expression. Well, we'll remove grouping symbols and combine like terms in the numerator. So remember to distribute 2x times, excuse me, x to the fourth is 2x to the fifth. 2x times 5 is 10x. Okay, then I have a negative 4x to the third times x squared. So that would be negative 4x to the fifth and a negative 4x to the third times a negative 2x. So that would be a positive 8x to the third. And again, this is all divided by x to the fourth plus 5. Well, we can combine the like terms of 2x to the fifth and negative 4x to the fifth, and we're left with negative 2x to the fifth plus 8x to the third plus 10x all over x to the fourth plus 5. We have the derivative, and it's probably about as simple as we're going to make it right now. So let's set it equal to 0. I should do this perhaps on a different line. This, remember, was the second step in our strategy here. Now I can multiply both sides by x to the fourth plus 5. On the left, I'll simply have a negative 2x to the fifth plus 8x to the third plus 10x, because the x to the fourth plus 5 will cancel. On the right side, since I'm multiplying by 0, I just have 0. Okay. We can factor out a common factor of 2x, but I'll factor out a negative 2x so that the leading coefficient on what's left will be positive. So I'll take out a negative 2x, and I'll have left x to the fourth minus 4x squared minus 5 is equal to 0. This expression can be factored, so we have negative 2x times x squared minus 5x, minus 5 times x squared plus 1 is equal to 0. Let me just double check that. X to the fourth, x squared minus 5x squared is negative 4x squared negative 5. Okay, we're right. So let's see, the solutions will be to this equation when we solve for x. We're at that point right now. We'll have, all right, negative 2x equals 0, which means x is equal to 0, and we saw that there was a place where the horizontal, where the tangent was, that 0 was a place where the tangent was horizontal. X squared minus 5 equals 0, so x squared is equal to 5, and x is equal to plus or minus the square root of 5. Okay. And then finally, x squared plus 1 equals 0, or x squared is equal to negative 1, and so there's no real solutions. Okay, so we have our values of x. Our x is equal to 0, negative square root of 5, and square root of 5. Let's go back up and return to the graph for just a second. And notice this was where x was 0. Here we'd be at negative the square root of 5. Here would be positive the square root of 5.